would be the title then? I mean, the research topic.
Yeah, right. You have to have a topic as well.
Actually, I mean, like, I'm quite intrigued in one of the project that Mats is driving right now around what does it take for industry to succeed in the data and AI age. I think this is a brilliant topic, by the way. And I think for me, the topic is basically working on the people side, the operational side of AI and tech. So what I work on a daily basis is actually not executive level. It's almost not even middle manager level. It's quite operational, but not the tech, the other stuff that you need to get right in order to succeed with data and AI. And to be, so here is the research topic around what's the operating model, how do I work in interdisciplinary teams between AI and data and business people? How do I create a common lingo so we can work more efficiently together? How do I have a common use case lifecycle?
We have so many different ways where the technical AI part, building the best model we can think of. Then we have the operational part, making it work for real. But we also have the organizational part of AI.
Yes.
Your title could be organizational AI.
So I want to do organizational and people ways of working research on AI. And this is and with the interdisciplinary focus. I think the problem is not that we don't know how to do an AI process or a software development process or a business process. The problem is how do we now go from ideation to production?
Exactly.
At scale, given we have meeting a legacy analog domain with a data and AI domain. I joke and say, my father is a doctor, he speaks Latin, and here comes a new guy and speaks Python. How can they work together? We need to give them a new language.
That's a crucial position. So
this is my research, by the way. Could you have me?
Amazing. I'm part of a few projects. There are actually different people with different backgrounds. So one of the projects that I'm working on is about papers, cellulose papers. Yeah. And then people in the paper side, they have no idea about machine learning, AI, and so on. And I have my knowledge in papers is
zero. Cellulose. I mean, like,
what is cellulose?
What is cellulose? I mean, like now we are talking. Yeah, I guess it's molecules. Some stuff like this. Yeah.
And then, so we need someone to connect us to us. Because, for example, I present what is AI to them. These are the benefits of using machine learning, deep learning to facilitate many processes. And then, after finishing the presentation, I wait for them. Is anybody of you are interested to actually use these techniques in the work? Silence. And after a while, I contact, are you interested? Nobody answered. And someone explicitly answered, no, we are not interested at all. So what should I do? I need someone to be able to translate what I mean in their domain.
Yeah.
I think that's a great topic, organizational AI. That's
organizational aspects of AI, something like this.
Yeah.
And Amir, you're also in the process of becoming a docent, right?
Yes.
Or how do you say it in English? Do you say docent?
Docent, yeah.
Docent.
I think it's a quite Swedish title.
Docent, is that actually an English academic title, or is it a Swedish one?
That's a Swedish title.
I think it is.
Yeah. It's like licentiate, it's
licentiate.
So it's like that's like a halfway PhD, and docent is like a double PhD, right? Or
exactly. And again, licentiate is also the Swedish title, so we don't have it in any other countries, as long as I know.
And why do one wants to become a docent?
So docent, as I mentioned, is a title that gives this permission or promote people to be able to be the main supervisor of the PhD students. Because if you have a PhD, you can be a supervisor of the PhD students, but as a co-supervisor, you cannot
be alone.
You cannot be alone. You should be with someone, a professor, or someone who has docent. Not maybe associate or someone. And to be able to be the main supervisor of someone, you need to apply for the docent, and then when you receive the docentship, and then
so it's really a certificate of your level of mastery that you have done PhD, you have done this. Now you have co-supervised. Exactly. Now you're ready to supervise alone. And then basically, yes, I have on paper as a docent.
Exactly, and shows that you can be independently manage everything. You can
the whole project, so to speak.
Yes, exactly.
Which is then so it makes complete sense from a career ladder.
Exactly.
That this is the natural progression.
Yes.
Cool. So I think a lot of people are a bit confused now. So let's just try to summarize a bit the different, titles that we have from an academic point of view, and then you have work titles that you can have. And in Swedish we have universitetslektor, and that I guess is assistant professor.
Exactly.
And then you can become an associate professor, which is different from docent. And docent is just the academic title, right?
Yes.
And then you have a full professor as well.
Yeah, we have a tenure track actually planned for someone who goes to the to apply for as a faculty in the university, and in the tenure track you have these 3 steps: assistant, associate, full professor. And then it will help you, because after the assistant you need to apply to be associate. You can pass or fail, but if you have a docent, it will help you to pass this step.
Right. And someone said to me a full professor title or position is both. I mean, they claim potentially docent is the highest academic title.
Yes.
But others say that the professor is both an academic and work position. I don't know which is true there.
Yeah, so as long as I know, docent is a title, but the others are positions in the university. Yeah.
Right. Okay, a lot of confusing things, and American have different titles than Swedish one does, and UK have different with lecturer and readers and whatnot.
Yeah, exactly,
and,
different topics.
Why can't they just standardize everything?
Yeah, and during this track, during this tenure track, so how you have some time limit to promote it from assistant to associate.
Really? So if you don't do it, you can never do it?
It's done.
Really?
It's 4 years. But from associate to full professor, there is no time limit.
Right. And before, the full professorship was appointed by the government, right? But these days, or since the last 20 years or 15 years or something, it's from the university, right?
So actually, it's supported by the government. But anyway, if you want to be able to promote, you should have students. And to have students, you need to apply for the projects and receive funding to be able to make your own group. Yeah. Otherwise, if you want to work lonely, yes, it's supported by the government. But of course, you cannot.
I think, before, because it's just tell people how old I am, but before, I think in the beginning of 90s or something, then actually the professorship was appointed by the government, and then it was for life. So, but it's not that way anymore, as far as I know, in the Swedish universities. I think it's so, I think in Brazilian universities and things like that, they still have these kind of life positions, both for assistant professors and other things, if I remember correctly. But I'm
assistant
not sure.
Not, but from associate afterwards, it is permanent positions. So then, regardless of the funding,
you still have it.
You still have it.
Yeah. Awesome. Confusing, but very interesting, I think. With that, it's a pleasure to have you here, Amir Payberah. We have known each other a number of years and collaborate from Peltarion to KTH in a number of projects, PhD students and whatnot. So it's a pleasure to have you here. So with that, how would you describe yourself? Who is Amir Payberah?
Yeah, first of all, thanks for inviting me to this interesting podcast. So, my name is Amir Payberah. I am an assistant professor of computer systems at KTH and also a senior researcher at RISE, Research Institute of Sweden. And so my research topic include quite different areas. So, but I'm a system researcher person, mainly focused on systems. But at the moment, I'm supervising a number of students that are working on totally different topics, from reinforcement learning for game playing to NLP and explainability to parallelization of the deep learning, either data parallel, model parallel, and also making a kind of data-centric AI center at RISE. So it's actually, at the moment, I'm working on the totally different topics. But if I want to call myself, I'm a system researcher.
And when you define
researcher.
System, what is a system?
Yeah, so my main interest, actually, if I want to go back into history, so I started by, as soon as I finished my bachelor, I started working on hacking Linux kernel. So, and I found my interest in that level. So working on the very fundamental and from very baseline things. So
and when you say hacking, what do you mean specifically? Did you actually change the kernel itself? Or
yeah, exactly.
Try to hack into systems?
Hack into the system. For example, at that time, so it was around 2001. So like 20 years ago. So we were trying to implement kind of distributed firewall. And then we had to modify the stack, the network stack in the kernel. So then we modified.
And what do you mean a distributed firewall? How does that work?
So actually, it was mainly, the idea was the distributed firewall. So it was mainly, we wanted to have actually different machines with different, let's say, kernels, and they collaborate together to be able to filter out the packets are coming in and out. So, but it was a very naive approach, and it was a very...
But you mean the actual firewall software communicated between each other in that way, try to understand what was the...
The idea was something like this. But in reality, we never made it. It was just some rough idea that we were interested to do that. So we didn't have enough funding to do this. We were interested to build it. But some practical thing that I did, so since I did my bachelor in the computer architecture and hardware engineering, so I was building a number of devices and making device driver in Linux. And making some embedded Linux to support those devices.
Right.
For example, some I/O card, and we made some router. So we were in a group. So some people built the device, and we built the device drivers to support that device to be able to, route the packets.
But so this field of firewalls and cybersecurity in general is actually one of my passions as well.
Really?
So it's fun to speak about. And if you think about today, we see so many hacks going on and ransomware being sent to companies and whatnot. And what do you think about the field of cybersecurity? Would the idea of a distributed firewall potentially work better today, you think, to help companies become more secure? So
we should distinguish between security or privacy. Which one you make?
Okay. I think ransomware kind of security.
Security, but it's a good one. You make the distinction. It's not the same.
They're not the same. Yeah, exactly. So now, actually, we are working on the project to make a reliable or robust deep learning or distributed learning. So meaning that, just assume a federated learning. So we have a number of devices that each device has a identical copy of the model, regardless of the base. So we have a number of models that are communicating together. So iteratively, they get data, they train it, they need to aggregate the gradients to be able to go to the next round. But what if any of these workers or nodes are Byzantine?
Or what are
Byzantine or attacker?
Byzantine.
Byzantine, yes.
Fraud.
So they are the attacker or something.
Attacker, exactly.
So
and assume if that node, instead of sending a correct gradient, send any data. And then how can you make your models robust?
Against that kind of...
Yes, exactly. And then there are a number of papers considering using a centralized way of the aggregation. For example, one way to aggregate data in the data poly is to have a parameter server that collects all the gradients, apply the aggregation function, and send it back, and then update it. But what if we are working in fully distributed systems, distributed environment?
Okay.
So if there is no parameter server, so then how?
Like swarm learning kind of setting where it's
exactly.
only peer-to-peer.
Only peer-to-peer, exactly. How those nodes can communicate and find the aggregation of the gradients by kicking out the, let's say, the Byzantine nodes or attackers.
So let me be stupid here a little bit. Are we talking about different challenges or different approaches in this realm of federated machine learning? So federated machine learning, could that be the umbrella? Then we go into different problem scenarios in this, or is it not that? It's
I prefer not to use the term federated learning. I prefer to use some more generic term, which is called data parallel. So in the data parallel, it means that you have a number of nodes or workers, and they have their own models, but each model has its own data. In the federated learning, so it could be any device, it could be mobile devices, IoT, and so on, but it is not limited to that scenario. So you could have it in a cluster of the machines.
Okay, so FedML is more of a concrete scenario, and you are talking broader, where FedML is one scenario.
Yeah, that could be under umbrella of data parallel approach.
Okay, the data parallel approach sits above.
Yeah,
so as a more of an umbrella term.
Exactly, federated learning is based on that approach.
How would you take the term like decentralized models versus data parallel? Some people call like decentralized like an umbrella term of federated learning. Would you say it's similar to data parallel, or is it different? Or
yeah, exactly. So when we want to distinguish between centralized and decentralized, we can refer to where we aggregate data or gradients. So the aggregation can be the gradient can be aggregated centrally in the parameter server or in a fully distributed manner, for example, using ring-all-reduce.
Yeah, exactly.
But regardless of where we aggregate the gradients, the model is, or the approach is data parallel. And data parallel means that each worker has a copy of the model, but they have different parts of the data. Because another approach is model parallel, meaning that we have a model, but we partition into different parts, and each device has part of the model.
So one approach, you send the model around, and the other approach, you send the data around.
Exactly.
And taking once again one step back, why do we care about this? What's the problem that we are solving, or what's the future that we are anticipating? Why this is important?
Which one? The security or the parallelization?
Let's talk about we ended up in parallelization and distribution.
Yeah,
which is I think park it, by the way, because I want to explore architecture because I think the whole world becomes data and AI ecosystems connecting to different industry ecosystems, connecting companies inside a company or between companies. So I think the world is distributed whether we like it or not. But this is almost like a separate topic that we can.
So how would you describe that topic if we were to table it for now?
I would, what's the future AI ecosystem? How should we think about our architectural or design patterns to be data AI ready? If in my hypothesis, I think industries turns into ecosystems. I see manufacturing of trucks in Scania moving towards a transport ecosystem. And I think it's going to be underpinned by data and AI ecosystem. And we're going to have different actors and players where data needs to flow.
Yeah.
So this is the theme that I would like to go from strategic to hardcore, what it means. But we almost jumped there now, but I think it's a topic in itself.
Yeah, regarding your question, why it is important regarding why parallelization is important, so I can say that we are living in the big data era. So, and I can define big data in a very simple term.
That's an interesting why. Okay. And a big, okay. So how would you define big data?
I define big data according to the funny tweet.
Yes. Okay.
That's mentioned that if you load data into the memory of your computer, and if your computer crashes, then your data is big. Otherwise, it's not big. Really, so it means that you cannot use a single machine to process data. If you cannot use a single machine to process data, then you need to split it into different parts and then
process it differently.
Process in parallel using different machine, right? So,
Do you think it's only a matter of the volume of the data, or could it also be that the computational needs are too grave for a single machine?
Yeah, so for example, as you know, we have different V's. So we have
Yes.
volume, we have...
I was waiting for that one.
And the veracity is not a real entity or something like that.
Yeah, but these are the buzzwords. I prefer to use, if your computer crashes, then your data is big.
So for people that don't understand, we have the traditional 3 V's, and then I think it can 5
or
V's
even more.
or
Yeah,
But
exactly.
who came up with this? This was 2012 when someone said, "Oh, we need big data," right? And all of a sudden, it became it's a hype story, right?
Yes.
This is how you sell conferences. So we were selling big data conferences, and then it was the 4. At this time, it was 4. It's 3 turned 4. Is it 5 now?
I guess.
But it's very funny. So anytime that you come up or end up with this kind of terms in the community, so people try to use it without even understanding.
Yes.
There is a nice quote that says that.
Parroting.
Yeah, this says.
I've done it too. Sorry.
Yeah, it says that big data is like a teenager sex. All are talking about it. Nobody knows how to do it, and they think other people do it. So let's say
This is another T-shirt. Big data is like teenager sex.
So they say that okay, we are doing this, but actually nobody knows how to do it.
Yeah.
And big data, when it appears, it was like this. But
Everybody talks about it. No one's done it.
yeah.
I love it.
Okay. Anyway, so due to the big data that causes our machines to be crashed, we need a new way or new approach to be able to process data. And of course, when we have neural network, we still have data and big models. So we have 2 big things: big data, large volume of data, and big models, meaning that we have lots of the parameters or weights in the model.
Yeah.
So if we have only big or large volume of data, we can use data problem, meaning that we can split the data into different parts and load parts of the data on each worker or node. But if you have a large number of the weights or parameters, then we can use model parallelization. So meaning that we partition the model and then we put part of the model on different nodes.
Yeah.
And that's also one of the topics one of my students are working on, how to put different part of the models on different device. That is called device placement strategy. That's also very challenging.
Yeah. But I think this is a really good distinction when we talk about why we need to do parallel. It's a data problem, but it's also if you want to parallelize the model itself.
Yes. Or sometimes we need to have a combination, of course.
Yeah.
And the computational complexity, I would say. But yeah, sure. So if we're going to do a Swedish GPT-3, we certainly need some kind of model parallel approach.
Yes, exactly.
Let's hope we don't go there.
But how did you end up at KTH, or was that the is that where you started, or probably not?
Yeah, so
I don't know your background.
I came to KTH in 2008 actually. So I did my bachelor and master in Iran. I started my bachelor in 1996, and I was, as I mentioned, so I did my bachelor and master in computer architecture and hardware engineering. And then at that time, I realized that, I'm interested in distributed systems, distributed computing, and so on. So then I applied for another master in distributed systems at KTH in 2006. And then I started my master, the second master in distributed systems at KTH. And then I continue my PhD as an industrial PhD at 6. It was not RISE at that moment. It was 6, yes. And then after...
this is when because we had friends here from 6 that you, of course, know Lale and Fredrik.
Yeah, exactly, of course. And then I was there. I did my PhD at 6, and then after that I did a postdoc at KTH, and then I went to Oxford for 1.5 years. I did another postdoc, and then I applied for a faculty position at KTH.
And did you get invited, or was it something that, how did you end up in Oxford?
So I just went for a postdoc position. So I applied for the...
There was an opening coming up and you applied for it?
Exactly.
Perfect.
And what was the topic in Oxford for the postdoc?
So it was more an applied AI. It was totally different. So before that, I was mainly a system researcher and working on the peer-to-peer computing and also data-intensive computing platforms. But I've never worked on the applied AI, so I found it quite interesting. So then I joined it, and so it was on the epidemiology. So we apply machine learning, deep learning techniques for, epidemiology.
That's a hard word.
It's a very important one in these days.
Yeah,
Yes, exactly.
Wow, it's almost like spot on for...
And that's one of the places that you can see the impact of the real impact of the AI. Because, for example, it could improve some of the process that doctors do manually, and then you can improve them by taking advantage of ML and DL.
But can you just elaborate a bit more? What was the topic of epidemiology in Oxford that you worked with?
So actually, honestly, I'm not very good in the epidemiology. I know that was a division of epidemiology, but I was working on the project by applying machine learning, deep learning on the big healthcare data set, trying to extract some patterns and also...
So looking from a more macro point of view, was it the spread of different diseases, or what was the patterns you were trying to find?
So one of the main projects that we worked at Oxford was to make a unified representations for different data sets, because so we have different data sets with different patterns, and then so we would like to, for example, extract some pattern from them. The question is that how can we make a unified representations to be able to apply other algorithms? For example, then we compare different models. For example, we use some simple CNN model, or we use restricted Boltzmann machine and different other techniques to make a unified representations, and then that representation could be an input to other algorithms.
So it's like different encoders for different data sets?
Exactly.
And then you can use some generic model for all of them.
Generic representations for the different data sets.
So if I'm not really following it, like we have heterogeneous data sets that we want to unify in certain ways, in order to have them to compare them, even if they were, as long as they're heterogeneous, we can't really compare them. But if I can unify them, now we can do algorithms on the whole population.
Exactly. Assume you have a model you would like to apply in different data set, but each data set has its own schema.
Yeah, and as long as this is it, you can't really take any insight from it. But if you now unify it, you can have insight across.
Exactly.
Yeah, clear.
But actually, it was I was there only for 1.5 years, so I didn't complete and go into the deep, because I was in the middle of the period that I received the offer, and it was a bit sad that I had to live in the middle of the project. But so anyway, so
and this is back to
I came back to KTH, yes.
And this was what year approximately?
July 2018.
18. Oh yeah. So then you came back to KTH as
an assistant professor in computer science.
Well, I'm glad that you came back to Sweden at least.
Thanks.
So that's awesome.
And I asked you before the podcast, but how is the different branches around computer systems or AI?
Yeah.
How does it work? How is it organized? The divisions or departments?
Yeah. KTH has a number of schools, and each school focuses on a specific domain. We are part of the EECS School, Electronic Engineering and Computer Science. It has a number of the departments under EECS. Computer Science is one of the departments, and under Computer Science department, we have 5 divisions, and Software and Computer Systems is one of the divisions, and I'm part of that.
And what is the sort of one-liner, what this department mission is or focus is that you're working in?
The department I think is a kind of logical term. It's not a physical thing, but divisions are physical things. Mm-hmm. It's like umbrella to cover some management.
Yeah, but if you frame the management of the department you're in, what's
or division, perhaps?
Or division.
Division.
Yeah,
yes.
Correct. Division.
So division is software and computer systems. So the topics that we cover in that divisions are distributed systems, networking, both in the low level and high level. High level, I mean in the graph level, and software engineering, and also DevOps. So these are the different topics that we are working, but I'm mainly working on the distributed systems group. But it is called distributed systems group. But now, as I mentioned, I have students on reinforcement learning, NLP, explainability, and also systems.
Okay, but this is you paint the picture, so I follow.
Yeah, good.
And you also give some courses, right?
Yes.
What kind of courses do you give?
So I'm giving 3 main courses at KTH. 2 of them are master levels, but PhD students can also take them. One of them is called Data Intensive Computing course, and the second one is called Scalable Machine Learning and Deep Learning. And I have a third course, which is a PhD level course called Systems for Scalable Machine Learning. So I designed the Data Intensive Computing course and Systems for Scalable Machine Learning from scratch. So we didn't have these courses at KTH, so I just designed them and registered them as a course. Because, after I finished my PhD, so during my PhD, I was working on the peer-to-peer system and peer-to-peer algorithms. I had no idea about data-intensive computing platforms. And it was 2013. At that moment, I heard a lot of buzzwords such as HDFS, Spark. It was the beginning of the Spark. There was not Fling, it was Stratosphere and some other terms. So I didn't know what was this term. So I say, okay, let's design a course to understand what is this.
Design the course to learn yourself.
I designed the course to learn it and say, okay.
This is smart. I want to learn this, so I will design the course. Yeah. Then I know what it is.
And then I figured, okay, so now I understand what are these topics. So why not to present and give it as a course to other people? And then present it first at 6, and I received very good feedback from the people at 6. And then in 2016, I didn't have any position at KTH at that moment. But as a guest lecturer, gave a complete course and received extremely good feedback. And then at that time, I registered officially as a KTH course. And then I continue it so far. And every year I have around 120 students, both from KTH, and some people are also coming from industry. Many people from Ericsson or any other companies are interested.
But this topic here is, I think, it's quite profound, and something that I have realized that I've been starting to talk about more without having the expert knowledge. So here I want to try something out with you, and I want to hear a real expert telling me off or telling me yes. And what I realized when I've been working both, in different large enterprises, is that I think we are entering into a completely new coding paradigm in many ways, right? But one of the easiest way to explain it is that 99% of the systems or applications we're building on is actually very, very little data that is created and mastered and sourced in the new system. So 80% of all the data, what the purpose of the workflow is coming from other systems. And then, so this is not so, for me, this is much more basic, but I think it's a problem because I meet a constant conversation around architectural, where I see anti-pattern or clashes between application-centric thinking and data-centric thinking. And the way I define this, or when we talk about this inside the company where I'm right now, it's a little bit like people want to build a whole stack, and they are thinking like, I have a user, to have an operating system, and I build it all like this. And a concrete example now is we're working on a project around lead generation. So generating leads to sell, right? But the reality is that when you build a lead generation system and want to identify leads and recommend leads, it's based on data that comes from many different source systems.
Yes.
And this application or system sits somewhere in the middle, like a backend. It's a recommender system in a way. And then it should go to in front of some salesperson who should use it. But still, I end up people discussing what is this system? Can we buy this as a software, and can we buy this as a full stack? And I'm like, no. This is something else. This is a data product. This is a different way of coding and thinking when you code, when you're not really there. Like the data already exists. You're going to channel data. You're going to fuel data. Data, all this, right?
Yeah.
But people then have a application-centric mindset, and all of a sudden we are building things in silos and silos. Is this the same stuff? But do you see, when I say data-centric in this way, do you agree with that, or is it completely off? Because I'm not the technical guy and I'm not the trained guy here, but I see a problem.
Yeah, I see. So yes and no. Actually, what I meant by data-intensive computing platforms, I'm purely talking about the platforms, I'm not talking about the full stack. But I can categorize these platforms into two big, let's say, categories. The platforms that we can use to store data, platforms that we can use to process data. Whatever you define could be built on top of that.
Yeah. So storage.
Potentially, I think this is a separate topic in itself, and I think we should end off with the courses and everything, and then perhaps move more into the data-centric versus application-centric, and how we build applications and systems of systems.
It's great. I did the rabbit hole. I
think we're sparing off a bit in discussions here. So before we move into that, but I added it to the list so we can come back to that later.
Sure.
But okay, so you give a number of courses like data-intensive computing and scalable ML and systems for scalable ML. And if we just start with the first course, like data-intensive computing, if that's it, what type of technologies more specifically are you teaching these days in that course?
So, as I mentioned, so in the beginning, I realized we have lots of platforms. We need some, let's say, schema or framework to give a big picture to me to understand what I should put in each of these platforms. So then I define kind of, let's say, a stack. It's not the same stack as you mentioned, but I define a stack and they say, okay, this stack has a number of layers. Yes. And each layer, I define a number of the platforms that can be put in that layer. So one layer is the storage layer that we can use to store data. And then that layer can cover different type of the platform. One is distributed file system that we can store raw data, NoSQL databases that we can use data but with more, let's say, schema, or we can apply some queries on them, and then storage for streaming data. We can call them as a messaging system such as Kafka and any other system. So these are the platforms that I can use in the layer for storage. On top of that, we have we have a layer that covers the platforms that we can use to process data.
The compute part, sure.
Yes, exactly. And that layer has a number of components. The platforms that we can use to process batch data, the component that can be used to process streaming data, graph data, structured data, and applying higher level to analyze ML or apply ML and DL. And on the bottom of this stack, I put the frameworks or platforms that we can use to manage resources such as Mesos and Yarn and so on. But the main, let's say, technology that I build the course based on is Spark.
Yeah. And I think a lot of people say it's one of the leading, at least, open source solutions for big data processing. Would you agree with that today?
Spark?
Yeah.
I think Spark is kind of leading.
Yes.
Of course, we are working on similar projects with maybe even stronger approaches in some parts, such as Flink, that we build part of it at KTH and Rise. Still believe Spark is ahead of.
So Spark and Flink, it's kind of a war between the two, I would say.
We've talked before about we had some Julia advocates versus Python advocates. So now, can we contrast Flink and Spark, and what type of language is Spark?
Flink is the Julia, and Spark is the Python, I would say. I'm not sure if you agree, but
I understand exactly what you mean. Everybody uses Spark. The open libraries are in Spark. Yada yada yada.
Yeah. So actually,
but what does Spark do? I mean, like Python does something. What does Spark do? Hardcore. As a lingo.
So the main idea of the Spark was the following. So in the very beginning, we had MapReduce.
Yes.
So the MapReduce work as the following. So we have data source. For example, we have HDFS. Then we read data. We apply a map function. Then we create some intermediate key value result, give it to the reuse function. It applies the reduce function, and then we store into the HDFS. That's it. It works fine, but the whole data flow has only these two components, map and reduce. But if you want to make a more complex data flow, how can you do that? So then we have Java, Flume Java, that provides you some APIs to build such a complex pipeline, or let's say data flow, but it is translated to a sequence of MapReduce tasks. So between each MapReduce task, the reducer should write the result into the HDFS, and the next mapper should read it from the HDFS. It works, but it's very slow. So the idea of the Spark was the following. Let's use that one. Let's define some APIs to be able to define that data flow easily, but get rid of these intermediate HDFS and keep all the data in the memory. But then there is a question. So in that HDFS approach, so it was clear if there is some failure happens, so then I can go to the previous HDFS and read the data from that and continue the rest of the project. But in Spark, the data is in the memory.
Not only, I mean, it can flow to disk.
But the performance comes from by storing data in the memory. So the question was that if some failure happens, how can we recover the data? So they said, okay, while we are defining the data flow, we are just creating a lineage graph. And lineage graph means that we put set of the operations, and then the data that was based on the structure called RDD at that point, but now RDD is not being used. In reality, mainly data frame and data sets are going to be used. But anyway, so RDDs are passing from operation to another operation. While we are creating data flow, we just create that DAG and direct the acyclic graph. And then, so if some failure happens, I can go back through this DAG until I come up with some node that has the final and correct version of the RDD, and I can redo the operation from that moment
on the last bit.
And since that data is in the memory, repeating the process is very fast. That's actually the winning point of the Spark.
Sorry for going a bit more technical here.
Yes.
Now, this is actually, I love this topic as well, but this is going to be even more technical. So, Spark is building up an execution graph, right?
Yes.
Of different tasks to do, and they can be map tasks and reduce tasks and whatnot. And then we have potentially TensorFlow in the middle of that.
Yeah.
It also builds up an execution graph, or a graph of the operations going to do with different, TensorFlow operations that they have. And how do you debug a system that is using both these kind of lazy execution graphs in Spark land and also in TensorFlow land?
Yeah. So actually, both Spark and, let's say, TensorFlow, the idea behind them are totally different. The idea of the Spark to be able to apply batch processing at scale, but TensorFlow is to facilitate making neural networks. So usually the existing system that use both TensorFlow and, let's say, Spark, they built TensorFlow on top of Spark. It's not merged. So actually it's being run on top of that. For example, a platform that we built at Logical Clocks and KTH is called Maggie for hyperparameter tuning. Yeah. So assume you want to train a model but with different hyperparameters. One approach is to make a Spark cluster, and then so parallelization is being managed by Spark, but each worker runs one TensorFlow, and then they are being run in parallel.
I think we're going a bit too deep here, but I think I add this topic, I think, to later, because I think this is a very interesting topic when it comes to how do you make an efficient development environment in general, where you can debug and troubleshoot and understand, the horrible stack traces that do occur in Spark land, and even worse in TensorFlow land. And when you combine the two, it's like, yeah. But okay, this is a very interesting topic. But let's come back to that potentially if we have time. Sure. Okay, so you have a data-intensive course. Yeah. And then you also have a scalable ML course and something called systems for scalable. So what's the difference between the two?
Okay, so a scalable machine learning deep learning course is a course for master's students. So, and the topics that I cover in that course has two parts. I cover machine learning and deep learning, and then for the machine learning, I cover the concepts of the machine learning, for example, supervised and so on, classification and regression, and other types of the algorithms in ML. And then, as a system perspective, I cover Spark ML and present how to build all these applications using a Spark ML. That's one part of the course. The second part of the course is deep learning. So again, I cover different concepts in deep learning and then present how to implement them using TensorFlow and Keras. That's a scalable machine learning deep learning course. But the third course, which is called Systems for Machine Learning Deep Learning, I designed for a PhD student. That's mainly a research based course. So, and in that course, I cover the fundamental challenges that we need to actually solve for system for machine learning, such as parallelizations, either data parallel and model parallel, robust learning,
robots learning?
Robust
learning.
Robust learning. Okay. AutoML.
Yeah.
And these are the main topics that we cover in that course, and then we go into the deep in any of these concepts and then discuss with the students.
So, I'm very eager to go more into depth into like AutoML and robust learning as well, but perhaps later. And then, so you have a number of courses, and you also do you have a research group as well, or
yes.
And can you
officially? I cannot.
Yes,
but
you have.
I made it.
You are working with a team around those key areas that you have highlighted before.
Exactly. I have 7 students and 1 postdoc, and of course a number of master's students. I called our group, which is not officially registered as a Scales.
What?
Scales.
Scales.
Scales. Yes.
Oh, okay.
Scalable learning.
Okay. And do you have what's the latest or greatest publications you and your team or you've been working on that you just recently published or that you are planning to publish in the near future?
So actually from last December, it was actually a very good time. So we published more than 10 papers. So,
wow.
So
that's productive.
That's very productive time. So if I want to,
which one is then like pick one.
So I can. Yeah. So there was one paper that is not part of any of these active research topic that I'm working on, but that's a paper that we published with one of the master students in the conference called ISPA, and we got the best paper award for that paper. And now it's part of the production at the Spotify. It is in API. So that's actually...
So something that was rewarded that then is has made it to production.
Exactly, and it's only based on the one master thesis. So it's very perfect.
It's like a master thesis can also be good.
Yes, exactly. It's only 6 months work with the one master thesis. It's only 2 of us, and then we received.
So how proud were you of your master student? This is amazing stuff.
That's amazing. So and it's about joining massive data, but repeated join. But by repeated joins, it means that. So, assume you have 2 data sets, you would like to join them, but for any reason you cannot materialize the result of the join, and anytime you have to, let's say, join them,
do it again,
repeat it. So how we can do it in an efficient way? That's all. That was actually the idea of that paper.
Can you go a bit more into technical depth there, or is there anything secret about the solution? Or can you give, for example, just give some concrete example of what they did in Spotify to make use of this result? Or were they trying to join playlists? Or?
Yeah, I can give some example. Assume you have a data set of the users and data set of the, let's say, profiles. Okay, but for any reason, you don't want to keep the user IDs with the, let's say, for example, profiles or playlists or whatever. So each of them is associated with the keys. So for any operations that you want to do, you need to join. Yeah, you need to join them. Yeah. But as I mentioned, so for the privacy reasons, you cannot keep the
together
to get them together. Exactly, and then you need to repeat it again.
So then every time you have a question, the join needs to be done.
Exactly, and
in real time. Join in real time?
It is not. It is in a batch, but it's being repeated in several. And these 2 data sets are huge.
And what was the solution then? How do you, without storing the combinational IDs, still make it efficient from a repeatable point of view?
I need to remember. So maybe we can skip this question because I don't remember at the moment.
Usually when someone says that, it means they don't want to divulge the information. But let's skip that.
But the paper is available and the source code is also available.
Cool.
But let's not make it too easy, right? If someone wants to steal a good idea, they need to work a little bit.
Yeah. So since actually I'm working probably in different topics, I don't have it really in my mind. So what we did is
cool. Amen is amazing stuff. Great, Amir. I think we covered most of your background now and what you're working with in terms of different research areas. And you also have some PhD students that you supervise, right?
Yeah.
Can you mention some PhD students, perhaps?
So I have 7 PhD students. One of them is a joint work with you that we are working on the explainability and NLP. We have another student together with King, and we are working on reinforcement learning for game playing. And the main focus is how to make it generalized solutions for agents to play different games. For example, you may train an agent that plays very well on one level, but how can you generalize it to play well in different levels? And how to make it scalable, considering you have lots of data that you need to be used to train the agent.
For people who don't know King is the company that produced the Candy Crush.
Yes, exactly.
And I need to do a little bit. I need to double check. So working in the King's research team. With Sahar?
Yes, exactly. So that's a joint work with Sahar.
She was on the podcast.
Yeah, she was on the podcast. Exactly. So it's a small little world.
It's a small world, exactly. So we applied for...
So we say hello to Sahar.
Yeah, sure. So we applied for a WASP proposal together last year, and based on that we started this joint project. It's called Scalable Generalized Reinforcement Learning for Game Playing. And then I have co-supervisor of 2 students who are working on a project called Extreme Earth. And in that project, so the project is to use machine learning for processing Earth observation data, but our focus is mainly on the parallelization. So one of them is working on data The other one is working on the model parallel. I also co-supervise 2 new PhD students who are part of the new Horizon 2020. I think it's the last proposal based on the last call in Horizon 2020. So it's called Data Cloud. And again, here in this...
Sorry, Data Cloud?
Data Cloud, yes.
Okay.
It is our task in this project. That's, again, a European project with more than 10 partners. So our role in this project is to make a kind of high-level language or DSL, domain-specific language, to be able to present a data flow for different people with not expert in AI. So it's more about making a DSL. That's a topic I just started, so I didn't list it in my research activities. It's quite new. And I have a student who is going to finish soon. He's working on cloud orchestrations and auto scaling. So we are using kind of machine learning approach for resource allocations.
Resource allocation optimization.
Yes, exactly. And in the latest paper that we published in CCGRIT this year, we use imitation learning to be able to auto scale the resources in the cloud environment.
That's pretty sexy stuff. Pretty cool stuff.
So if the research come up with some nice results for the Data Cloud projects, what could it be potentially used for, you would say?
So it would be very useful for non-AI expert or non-computer science expert people. So, and actually that's my goal in the research at the moment. So I try to facilitate it and make it easy for people to use it, because now machine learning, deep learning provides a lot of capability for people, but it is biased toward who knows these concepts. Many people cannot.
Similar to a vision of a company I know.
Yes, exactly.
Yes.
But it's this whole idea, scarcity to abundance, that we have something, we have abundance of data, but scarcity of value out of it. And in order to get abundance out of value and abundance out of AI, typically it has some sort of storyline of simplification or user friendliness.
Exactly.
The whole example with internet, starting with the DARPANET and all that, and then the browser changes everything, right?
Exactly.
And I think that's the general logic that has to happen. How do we go from scarcity to abundance around AI?
Exactly.
You need to then take this direction.
Exactly. And that's my kind of research topic that at RISE. So because RISE, the focus on my RISE is none of the topics that I mentioned now. So at RISE, we are focusing on building an AI center. And we want to build that AI center for, again, non-AI expert people. So at the moment, I'm working with 2 master students on 2 projects. And the idea of these 2 projects is the following. First, and the first topic is to make solutions for people who can write their questions or query or demands in text, and then the system can give them some relevant code that they can use. Doesn't convert it to the code, but we assume that we have a big repository of the code, we have a big repository of the data, which are not annotated. Okay. Now you write your code and your question, such as you do in the Stack Overflow. And then you would like to rank, for example, filter the available source code and then propose to the user. Or another topic that another student is working on is clustering the code based on their functionality. Assume again you have a large amount of the source code. They're working different tasks. So again, we are using some kind of NLP approach to simplify and cluster the code. For example, I'm saying that I'm looking for code with that functionality. So one of the basic components in that center should be a module to cluster the codes.
Mm.
Yeah.
So for the first part of trying to use a big repository of different code bases and then answering natural language questions to it, would it be fair to say it's like a question answering system, but with the query being natural language and then the answer being code?
Exactly.
So it could be like I write a simple like query saying, I want to do a binary search functionality in Python.
Something like this.
And then it actually suggests the piece of code directly saying this is the way to do it.
Yeah, it can, for example, returns 10 codes and these 10 codes with a high probability.
So a retrieval kind of.
Yes, exactly.
Yes.
Actually, what we wrote is based on that idea.
Yeah. Awesome.
And Angel is working on it.
Oh, really?
Yeah.
Cool. Yeah, it's an awesome student.
But now I think we should formally start a topic.
Yes.
And we have so many. I have so many great topics.
Yes. Do you want to take one first, or should I choose one?
I mean, I think to talk about data-centric versus application-centric is a good entry point.
Yeah.
And then I would like to have a real deep conversation on what we think about the future of the monolithic versus distributed systems. Because I think the world is distributed, but I don't think that shows up yet enough in how we think in general enterprise. So those are two main very interesting themes, I think. Yeah. Okay. But maybe it's good to start with application-centric as data-centric because it's a logical.
Try to frame a good question for Amir then.
Okay, yeah. So in my opinion, we are coming from like a journey of coding, software development, and an outlook on the world. In the 90s, we built applications, and we learned how to do an application stack. From the lowest level operating layer, and then to the logic, to the GUI for one application. And then right now we are living in the world where these two universes, I think, still clash. They have not converged yet. So I can go and talk to, it clashes even inside companies. So I can go to Microsoft, and Microsoft can say, we have the platform for you. What's the platform? It's Dynamics. And now we talk about Microsoft Dynamics, CRM, finance systems, application-centric thinking, and they're starting to grow fatter and fatter monolithic applications. And here I come now, and I can go to the cloud stack of Azure, which is more about, fundamentally, layering, decoupling, storage, compute, logic, and basically giving me the toolbox to think differently. And what I see now in the big enterprises is that based on where your legacy is, so I've been working with the Dynamics team since I grew up, and I've been working in the big data space. We are basically not really understanding the world of design and architecture the same way. We say platform, yeah. So for me, could we have a definition and differentiation? What is application-centric and what is data-centric way of developing and coding? And what is then platform in all of this? So something like distinguishing a bit too and what we think about that. And then, so that's sort of the floor is yours to take this in any direction. Yes. But this is sort of this is the problem I'm facing, that you are not talking about the same stuff.
Mm-hmm. Yeah. So, but apart from the application versus data-driven approaches, so if we consider the monotonic and the distributed approach, so it's a very long and old clash between these two approaches. So I remember, for example, when I was reading the operating system course, so I remember there is a clash between Tannenbaum and Linus Torvald. What's the guy behind Linux? Torvald, yeah, Linus Torvald. So that was the conflict between monotonic and modular ones. So, for example, Tannenbaum had a very nice operating system called Minix. It was modular, and then it was lightweight, and it could work properly. But due to that nature, so we may lose some performance because of that modularity. But Torvald proposed, okay, let's make a more monotonic approach and then have, let's say, Linux kernel and Linux operating system, GNU Linux, and then build that. So actually, it's a very long history between these two. So I myself, I'm more modular person, and I prefer that approach because it gives you more freedom to invent new things and then actually communicate with different techniques and approaches. Although if you have a more monotonic approach, so you achieve a very good performance because everything is built in one system and then you get rid of a lot of overhead of the communications. But if you, for example, again, look at the operating system perspective in the very beginning version of the Windows, even the X or user interface is part of the, let's say, the kernel. So it's awful, but it's, of course, it worked fine. But yeah, that's a kind of clash between these two approaches. But if you come to the data-driven and application, so what was the question?
No, is there a difference, or how do we contrast application-centric development and architecture with more data-centric? Is there such a thing? Is there a difference? And my definition is a little bit like, here is the full stack application. It's good for a business purpose, the whole stack. The problem becomes in a huge enterprise, I have hundreds of these applications in a siloed stack, and the data is not really functioning so well. And now I realize I can actually build these platforms, data on a platform where I can build different microservices and then join them together in front ends in different ways. So for me, it's like building microservices on a platform and reaching the same result. And here we have full application stacks, but the problem is it's not one; it's thousands.
Yeah. Actually, these days, and due to the having massive amount of data, that kind of data-driven approach is kind of, we can say that that's a de facto or the main approach that many platforms are built on. So because
for me, it's very simple. When I look at the data natives or looking at technology-driven companies that has sort of grown up from scratch, like Spotify, they have a certain architectural culture or design, I think.
But I'm trying to understand what you mean as well. I'm not fully sure if I understand you correctly either. I mean, for one, you can think about the monolithic kind of application structure, and you can think about the microservice kind of architecture.
Yeah.
But on the other side, you can think more of building application with a traditional software engineering mindset versus having a more machine learning, data-driven mindset. And I'm not sure which one you're referring to here.
Okay, so it's a little bit like, let's take this anywhere, because we throw around application-centric versus data-centric. Even I do that. Okay, and to some degree, I think there are many perspectives on that. So one argument could be, do I as an enterprise go out and buy off-the-shelf vendor applications one after another, and then I try to integrate a lot of different full-stack applications? So it's a little bit like, I don't even build my own applications. I buy off the shelf and then integrate. If I look at the big enterprise, this is how it works. We have an SAP application, we have a Dynamics. So this is one angle. And next to this, this exists and it still will exist, we are now starting to build things on the data platform. And then of course, then we can come into, how do we build on the data platform? Do we build monolithic or do we build microservices? But my starting point was...
Can you give some concrete example? Because I don't follow either, actually. What do you mean with data-centric in that view? Do you mean actually data-driven applications more than code-driven? Or what? Can you give an example, perhaps, to just clarify what you mean? Or did you follow? I didn't really follow.
I need some clarification.
Yes. Yeah, sorry. This is my layman that shines through. I mean, like, so for me, okay, maybe I'm trying to do too many things in one. I need to separate it into different questions. Okay, first conversation is about full stack application, whether you bought it or built it, and then you have many next to each other, and then try to integrate that in order to get data.
More component based versus building the whole stack yourself. Is that what you're saying?
Yeah, this is one example. So how do I work, application centric in this way, buying applications, so to speak. Then I think the other conversation is about I don't know how to frame it correctly.
But give a concrete example if you can. I think that would make it much more clear for everyone.
Okay, so the concrete example is this, that we have a lot of data sitting in different source systems, right? And we now need to build an application that does a certain component function. And ultimately, that function needs to be used by someone, so there needs to be some sort of GUI. I then see examples of people basically treating this like I build a new software application from scratch. Like I go in and do it like it wasn't residing on a platform, but like I was inventing a new software. And then I build the whole stack for this purpose. And then ultimately, in the end, I integrate data from different parts, traditional way, ETL or whatever, and then I model everything in here, and then basically from here I build a GUI inside the own application, and I now present an end-to-end application I built from scratch as an application
or as a service.
As a service, right? Okay, good. Alternatively, I realized that this is actually a bunch of data coming from different data that needs to be transformed for different reasons. I'm not even necessarily talking about that this is becoming machine learning or AI driven. It's simply, it's just a bunch of data transformation that you need to do in order to create the logic. There's no need for you to build a new proprietary stack. You can build data pipelines. You can have you can follow your pipelines according to your templates that you have in GitLab, GitHub. So you basically you approach to come to the logic outcome of whatever you need to create. Platform centric, based on that actually reusing data. And by the way, these design patterns could be reused and these data sets could be reused. So I'm not thinking from scratch proprietary new application.
Yeah, I see. Actually, I think I don't distinct these two approaches. So for example, as you mentioned, for the application based, so by having a GUI on top of the let's say platform behind it that we can feed different data. So for example, now what at Peltorium we have, so we have such a thing. So we have a service that you can use different data, and that in that interface we can use different algorithms to extract some knowledge from data. Or for example, what Logical Clocks does with HubSpot, so it provides an interface, gives you this capability to use, for example, Spark or TensorFlow, PyTorch, and then use any data that it has in the HubSpot, in the data storage. So in the backend, it's kind of so the way that you use that platforms are based kind of data-driven way of using that application. But that application is kind of the service that you can buy or you can build yourself. So I don't see
so for me
clear border between these.
No, maybe I think it's even here we're working on some sort of platform in the end, like AWS or GCP or something like that, and we have data here, and now we have a software as a service Peltorium module where I'm sending data in and then sending it back. For me, this is still microservices, modular thinking.
You call it microservices, okay.
I don't know what to call it, but to me, it's literally like, this is modular thinking. Okay. I call on another service, right? But what I meet is basically, and now we have this new topic. We are not at all on the platform. It's more like someone wants to build a standalone application from scratch that doesn't really talk to anything, and then we hook up. I don't know. Maybe it's the same. Maybe it's not. I mean, to me, it doesn't really fit the platform paradigm. It's a little bit like it's a standalone. This is a standalone application. This is completely standalone.
I agree. That would.
And now we have hundreds of them, and we could have translated that into modular application or microservices that more worked well together.
It could be, but actually, assume you want to extract some knowledge from data, but you can take advantage of any of the existing services, for example.
Yes.
You can use Peltorium service to apply some deep learning algorithm on your data, or maybe you can build a standalone application to make your pipeline from data ingestion, data cleaning, data engineering, and then make your model and so on. So, of course, you can build it from scratch by just using, for example, Spark ML, or use some existing frameworks, just put modular the components one after each other and then execute it. So,
in short, can we simply summarize it as, of course, a modular approach is better as long as it doesn't provide too much overhead to the system
exactly,
itself, right?
Yeah. So maybe this is a simple fundamental. Data-centric has more about to do modular, building Lego pieces.
But I don't use the data-centric to distinguish these two, because even in that approach, you may use data as with the data-centric approach, you know.
So what's the correct definition of data-centric then? So if we, how would you frame it?
Take advantage. You have data. You want to use data as the main source to extract some information and knowledge.
I think it's, for me at least, if you perhaps not use the term data-centric but data-driven applications,
yes,
then I would say that instead of doing manually rule-based coding all the time for every piece of the functionality, you can actually automatically code some part of the system using data instead to become more data-driven, and that is basically machine learning in its core.
Exactly. You ask the algorithm to learn from the data it is given to it. For a simple technique would be you define some, for example, some let's say hard code if then else, and say, okay, if you have this data, do this. If you have this data, do this, else do this. That would be quite traditional approach. But maybe you don't know how to define these rules. You ask the algorithm itself to extract that rule from the data, and I call it data-driven.
But now this helped me a little bit, because I think the misconception in my definition of what I was talking about, I'm confusing two different concepts into one, and they are not so. It's not so good. So in the one hand, I'm talking about standalone application versus more modular mesh
microservice architecture.
So this is microservice architecture versus standalone application. And now we are talking, and you need to keep that as one topic.
Exactly.
And then we can talk about another coding paradigm. Do you handwrite the code, or do you do rule-based, or can I actually do data-driven coding, or basically I give the patterns and rules, and then machine learning-wise, I don't generate all the code. So it's actually two different. This is two different things that should. But I think people mix these up, even like I did now. That are not experts.
Let's hope
like
that we separate them. I think it's important to think from from a cloud computing point of view, where you try to abstract different layers when it comes to the hardware, operating system, applications, and then it's a different thing when it comes to building monolithic application. Think Klarna, and or the more microservice architecture that we otherwise can have, and then thirdly you can think about the data-driven versus more manually coding approach.
But that's
exactly. One is more about the architecture. The other one is more about how you react with the data, how you use data.
But I think these things is bread and butter to you guys. But to 99% of the enterprise world, this is not really clear.
No,
and because we meet that when what's the difference between data science, advanced analytics, and AI? And people put them in the same corner, and we try to talk about, we are talking about a new coding paradigm, data-driven coding. This has, you can use that for a data science, advanced analytics project. Many people in business put these even together, or say AI, the analytical ladder. So could we please put some time and thought?
But we have many topics now. I think we should move into some other topics as well. That's okay.
I just want to nail down data-driven coding. What's the coding paradigm here? We are not coding ourselves.
I mean, I think it's a classical definition of what machine learning really is. Without machine learning, you have to code all the rules yourself. If it means edge detection in images, or if it means text or whatnot, and instead you can use data to learn it automatically. And
you can define three, let's say, eras in the history. One is a rule-based that you define them manually. The second one is kind of you ask the model to learn the features, but you define the features of the data manually. In the third era, that we ask the model to learn from the data and also extract the features from the data itself. So these are the three. Yeah, so that's rule-based, ML, DL.
Yeah, and for me, I think the misconception here that when people say we do advanced analytics using ML and DL is a little bit like, it's like taking the next level of we do regression analysis is just another way of finding an insight or prediction where in fact it's a new coding paradigm.
I think the people that you're referring to, I think they're mainly talking about the applied machine learning, deep learning.
I think yes.
But let's try to cover some other topics as well.
Thank you.
And I think you also mentioned logical clocks a number of times and hops works, etc. Can you just perhaps for the listeners describe a bit what is logical clocks and what is hop works?
Yeah, logical clocks is a company that has a main product called HopsWorks. That's I'm not part of the logical clocks, but I'm working closely with them. So that's a platform and that gives you this facility to work with different processing data frameworks easily, such as Spark, Flink, TensorFlow, PyTorch, with a very simple, easy to use interface. You can define projects. It's like a GitHub-like project. So, for example, you create a project in a GitHub style. You upload your code, and you can upload your data in the storage called HopsFS. And then, of course, you can share the code and data among different projects. And then, using any of those platforms which are available in HopsWorks, you can process data. And of course, it supports different kind of prioritizations, data parallel, model parallel. And also, on the backend, it uses a very high performance with a very low latency data store, which is called HopsFS. It's based on the, let's say, HDFS, but it's a kind of HDFS uses a kind of centralized. It uses a centralized master to
single point of failure.
Single point of it. They replace it with a distributed environment to make it scalable and also improve the performance and reduce the latency. That's the whole idea of the HopsWorks.
There's a Swedish company that was born out of 6 or KTH or mix of the two, or what was it? Or
yes, exactly. And Jim Dolling is the CEO of the company. He's also an associate professor at KTH and also the CEO of the company.
Yeah. Awesome. And perhaps a topic that you like, Henrik, as well, is trying to distinguish other terminology questions like data warehouse, and data lake, and data mesh, and these kind of things. I'm not sure if you...
No, it's
not a perhaps favorite topic of yours? Or?
Yeah, we may skip this. I'm not good also in terms.
Yeah, okay. Let's skip that then. But I think, one other topic that I had was more when it comes to education. And we have the traditional type of education that you do perform in universities, and it's mainly for students. And then we have the other thing, which is more education for companies. And just to give an anecdote, I remember, in the Spotify days, we once said, we need to make more people familiar with data science. And then we said, okay, so how can we find an education that is suitable for employees at that company? And we tried to look around, and we couldn't find anything in the Swedish universities, and we finally ended up buying a very expensive workshop from England. And it was like 2-3 workshops, and people took them, and then is this it? Okay, so what do we do now? And it didn't really work well, and it was really expensive, and it was strange that we couldn't find anything suitable in Sweden. And now in Sweden, we do have a number of things happening, like the AI competence of Sweden, trying to find these kind of lifelong learning courses and other things. But I would love to hear what your thought is. How can we better provide education for companies that is not only for students, so to speak? Do you have any thinking about this?
Yeah, so I haven't thought for the companies, but I think one of the most important things to be able to teach and motivate people at the industry is to find relevant use cases in their domains, and then build the story of the course around that use cases that they have or the challenges that they have. Because I think one of the important factors to have a good course is to have a storyline, have a very smooth flow from the first lecture to the end lecture, and then you need to, if you want to motivate the students to follow it, it should be something relevant to them. And of course, in the companies, you should build all your course around the use cases that they have.
I fully agree with this. I think this is one of the key topics, right? I sometimes I talk about when you have a new piece of knowledge and you shoot it down in a well, where is the hooks that people can basically hook into the new knowledge so it doesn't just fall straight through? And the simple fact that you are then talking to people inside their domain, inside their comfort zone, a use case they understand, that's the hook, right? And exactly. That it's motivating. It's something that solves my problem, but it also somewhere that I can relate to. I can't relate to this piece, but now I can relate to it because you made the connection for me.
Exactly.
Well, let me challenge you a bit, Amir, then, and say that, okay, imagine that you were an employee at a company, perhaps a tech company, medical company, or whatnot, and you simply want to make sure that you are keeping up to date with the latest AI in some way. How would you, or perhaps how do you do that today? How are your personal way of educating yourself?
As an employee in the company?
Yes, I was thinking primarily that, but potentially even as a professor at KTH. How do you keep yourself up to date? How do you educate yourself?
So that's a good question.
You're a bit cheating in KTH because you have students and you know read papers so much because of that, etc. But still, if you were to just think, you want to make sure that you actually can be ahead of other students and other people. How do you educate yourself? Yeah.
So what I do, it's kind of cheating. So, but
yes.
let's use that cheating. So I follow the relevant conferences, the good conferences in the domain. So I look at the state of the art and follow the groups that working in that domain, and then
it's like research groups in different universities or companies or what?
Yes, exactly. Research group in different companies and universities. Skim the papers. Definitely, I cannot go through all the papers, but at least by looking at the abstract introduction, okay, I know these are the domains that are active now. And if I find them interesting, then I follow them. I define for myself not to go with the wave. But anyway, there is no...
The papers has all...
Yes,
always...
you have to follow. If you want to survive, if you want to be in the community, you need to follow that. I tried not to do that, but as long as I find some topic.
But how would that be different? We started out in Scania with data science. How do I keep up to date, or what is my adult continuous learning as a data scientist look like in Scania? Or how, is it individual? Is it an individual responsibility? To some degree, I think it is. But what do you do?
If I'm manager of the group, I definitely organize some reading group.
Reading group. Good
reading
idea.
groups. Yeah, reading groups to motivate people in the group. So maybe for each session, one person is responsible to look at for example, one conference, prepare a summary of the topics, not papers, the topics covered in that conference, and give presentation to the others. Maybe it is not relevant to all the people research topic in that group, but at least they know, okay, these are the active topics in the research. And if they find that topic interesting, they can follow that. But it is different between academia and university. So maybe I push more in the university for the people in my group. For example, if there's some paper in that topic, ask them to read that. But I think companies have other businesses.
The main difference is that they want to apply the knowledge not because it's cool or happy engineering, like Somil would have said, but because we have a concrete problem. We need to build something, put something in production, and we need to go.
I'm trying to draw a line here between traditional education. You go to take a course, it could be a number of months, or you take a whole program of years, and then coming to how do you keep up to date? How do you do lifelong learning in a company? And then trying to see, connect the dots. You as a scientist, you of course have a different way to obtain information, and you're reading state-of-the-art papers. Yeah. That's not really a suitable way for like non-experts to do it. But could we find some middle ground here? Could we find a way to have people that are interested in data science in companies, but perhaps not can take information from research papers directly? Can we find some middle ground here to try to educate people and keep people up to date in AI, also in companies some way? And could universities potentially play a role in that?
So it's a quite challenging question.
It's an impossible question because
it's not. I have a suggestion.
Yeah,
but
but then please, why I think then I ask. Good, I'm going to answer your question. Are we talking about data engineers and data scientists in the company, or are we talking about middle managers or other domain experts? So first of all,
let's take one. Is
it a data scientist that should be keeping up to track, or is it one of the managers?
Let's start with the data scientist then.
Yeah, because data scientists and data engineers would be different. For example, if as a data engineer, so you need to be familiar with the platforms, how they work, and so on. But maybe reading papers on that domain doesn't help you.
Yeah. Maybe you certify yourself on AWS and
exactly, but you don't care, for example, how the data actually, how the joint operation works in Spark.
Yeah, but to take certifications in Spark, to take certifications in AWS, to try different things and use what the big vendors actually puts a lot of good information out there. Yeah. How to use their, that's how they, make sure you have successful people because they are knowing how to use your platform. So there's a lot of certification you can take, back to the core vendors.
But are certifications really the thing? And I'm trying to get to this because you don't take certifications, right, anymore. I'm
not fan of the certificates. That's all.
Yes, yeah. That's not the way that you keep up to date. That's not the way I keep up to date. You may do it as a student because you want to get a job, but what happens afterwards? How do you actually keep up to date afterwards? I think that's a big empty void that I think universities are missing out a bit on.
I can talk about myself and how I educate me and how I update myself. The main thing that I try to do anytime that I'm going to start a new topic is to find a big picture of the whole domain. Yeah. What does it talk about? So otherwise, I may read different papers from different conferences, but these are just different part of the puzzle. I cannot put them together. I need to have a big picture and say, okay, this paper belongs to that part of the puzzle and so on. For a state-of-the-art or new topics, it's almost impossible to make it easily unless you spend lots of time by having reading groups and then discussing with people and so on. But for the companies, actually, it's quite challenging because I'm not sure if they have time to do that.
That's the point.
And unless you design a customized course for them based on their demands. And I think there is no generic answer to these questions. For example, if Ericsson says, I have this group that are working on 5G with this particular problem, so then I try to find relevant papers that somehow around that topic and then design the course based on. Otherwise, I think there is no generic answer for that question.
You were giving us the cliffhanger that you had
I have the answer to everything. Yes.
Oh, good.
No.
42.
42. Yes, exactly.
The Douglas answer.
Yeah. No. Of course not.
But you had some. Give us your hypothesis and let's shoot at it.
No, but it's one idea that we've been speaking about in the Swedish AI agenda, in AI Sweden, and other like national initiatives that we have in trying to just increase knowledge management and knowledge sharing in different ways. And it's actually based on use cases that we spoke a bit about before. And what we want to do is try to have some kind of continuous way. It doesn't really work with one-offs, I would say. Mm-hmm. So a one-off would be that you have a single, or 2 workshops, or you have a single course, or you take an online course for a day or 2 and take a certificate. But that's not really a sustainable way to gain information, I would argue. Mm-hmm. So a more proper way would be if it's like a natural part of your daily work to just keep up to date. But how do you do that then? So I don't want to go into all of this discussion because it will take a lot of time, but the idea is then this kind of use case library, best practices work that we're doing. So the idea is then as soon as you do something, as soon as you have if you do a project with King, for example, and reinforcement learning, and you come to some interesting conclusion, what you would do then is try to share that knowledge somehow. And how do you share that knowledge? Well, you perhaps try to concisely describe that use case and have some links to these are the people that did this. This is links to more information. And you have a very concise piece of information. This is the thing we have done right now. And then you start to build up like a library of these use cases. Exactly. And you continuously, like once a week, once a month or whatever, tries to talk about these things. And you can always go back and look through and try to find, similar kind of thing. I want to do this now. Well, then you look through the library and you find potential use case, and I see, here are links to more information. Here are the people.
So that's a nice idea.
Yeah. And
so do you use such a, let's say, approach at Platorium?
We started to build that. We don't have a ready-made solution for it, but we're trying to, together with AI Sweden, to work with that. Uh-huh. And basically have a set of like practical AI use cases from different organizations throughout Sweden, then really concisely describe, not a long report that no one reads.
Exactly.
But a short, concise description and then links to more information.
That's very important to give some hints where to read. So since I haven't worked in the company, so I'm not familiar how actually how much time people have in the companies. But while I was at 6, long time ago, so we built such a website. So these are the topics and these are the presentation related to that topic, and people could follow them.
And another alternative could be to have podcasts like this.
Exactly.
Actually, I seriously think that. I think if you follow and have good podcasts that actually give very informative information, it's an easily digestible kind of format that people can hopefully learn a lot from.
Exactly.
Right?
Yeah. And considering these, considering lots of videos in YouTube, you can also follow them.
But and used to maybe end the topic on one note. It's been an uprise and completely explosion of the online MOOCs or whatever they're called, like Coursera and all that. And we were talking here about education, but none of us mentioned what would have been the obvious. I mean, like people are making millions out of these platforms of training now. And isn't that a choice, or they don't really give us to us?
I think universities are missing out on something here. I think
but you have Stanford have theirs,
what I mean is KTH, for example, could have like a certified set of podcasts that they promote in some way and say, if you want to do this is something that we as an institution that has very high branding and credit can stand for, because there's so much noise out there. So it's super hard for normal people to find, what should I listen to or what should I not listen to? But if you come up with like use the term certified courses, podcasts, or blog articles or whatnot to read, I think it could be super useful.
Well, we have a number of the courses at least at KTH. So Professor Saif Haridi, so he made a number of courses on distributed algorithms a few years ago, and are available. So I'm not sure if they give any certification now, but
at least as long as KTH stands behind it and say, here's a recommendation from KTH.
Exactly.
I think that could be really useful.
I think it was for free. And since I believe in the in open source and actually spread the knowledge,
because there are a couple of worth mentioning here. Like I think the phenomenon is called MOOCs, mega online course,
massively online,
something like that. Course MOOCs, right? Yeah. And here it's that market exploded 2 to 3 years ago. Yeah. Is it working or not? Do flip or flop? Flip or flop? What do you think? Very quickly, flip or flop? Is it working? If someone is making a lot of money on it, is it working for the individual?
In the beginning, actually, I just followed one of these MOOCs in the very beginning.
Yeah,
I never applied for the certificate, but long time ago I watched some of the courses, but afterwards I didn't follow because they're a bit slow.
Yeah.
But it makes sense if you want to have a big audience, you need to consider
someone is making money. I think that's more interesting. But I think there's
I think that nobody's making money actually.
This is a pyramid game. Coursera is making money. It's not
even a pyramid game because it's so much noise out there. Yeah. So people basically would choose. I mean, we shouldn't look negative at it because if we're looking at data literacy that we are actually talking about and focusing on the AI divide, the online courses and certification is the way to go. We are actually providing knowledge to people with a very, very small amount of money. I mean, most of the courses these days, you can get it for free. And the reason why is that is because at the beginning, the educations and certified companies could have provided these educational platforms. Now, it's every single company in the world is providing some kind of certification. If you're Microsoft, it's going to be Microsoft Azure. Yeah. If it's now going Snowflake, it's going to be Snowflake. And then if there is like a company that is actually focusing on frameworks, they will have their own certification and many other things. So people actually have like a variety and a palette of things that they want, that they can choose to. And if you look at, do people make money? It's basically like saying, do musicians make money out of Spotify? No, they don't. No, but is it the same thing? Knowledge is basically right now like Spotify and music.
But just to close this off, I think there's actually one angle here we haven't touched, but I think it's actually one of the most important. And this is within the coders and developers that I have met that I think is cutting edge. They are in somehow, all of them, closely connected to their open source community. So basically, it starts with the papers, but then essentially they hang out at GitLab and GitHub, and they play around with, basically they get a hold of something, they spot a new cool thing, they go to the GitLab and GitHub library, and they play around with it. I mean, like I give you a concrete example, Frederick, that was here from RISE. I love it. He posts on LinkedIn, I found a really cool thing, and it's this GitHub library, I could do this, and it goes viral. So I think the whole to be a part of the open source community actively and contributing, I think that's a way to stay ahead of the game. And I would propose that the old companies needs to learn the ways of the new companies. That, if you really, what are the Google guys doing? Well, they are, contributing to TensorFlow. They are doing this. So get into the game, even if you're at Scania, right? I think that's how you learn.
Yeah.
You don't believe in
so
that?
Actually, I agree with the open source. So, and I myself, so at KTH, we are using a system for sharing the material with the students called Canvas, but it is not open to the.
No, but it's open source inside KTH.
What I do, I use a GitHub. All my courses are available on GitHub. So I put a page on github.io for any courses that
goosebumps.
To the students, and then why not?
Why not?
It should be free and available to all the people.
And why don't you like that idea with going into
open source in general is good, but the idea that people say just because Google just open source this model means that any company can use it is very flawed.
But that was not the question. The question is...
But it needs to be accentuated, I think. That it's not as simple as simply having a piece of code repository published to make it useful for a company. There's so much more.
But the core question we were talking about, how does people stay updated That's the question. I'm not. What you are.
I mean, that's a good point.
So the question the recommendation I was giving, if you want to stay updated, maybe you should participate in open source and hang around in GitHub and GitLab. That was all. Beyond that.
But as long as people don't confuse that with thinking that just because something is open source means
when I gave an example that was loaded, you jumped on my example. So I should have stayed away from the example.
No, you should just contextualize it properly.
But I have a question from you. So, what would motivate the people in the company to follow this?
Yeah. I think it's very challenging, and I think I'd love to have better support for lifelong learning. And some people like you and me and Henrik, we follow things in different channels, in blog articles, in open source, in research article and whatnot.
Not my boss tells me this.
But how can we make companies do that in a more, in a more easily ingestible format, so to speak, that works on scale?
Yeah.
That, I think, is an open question that we haven't really answered yet.
So some companies, for example, I know, for example, Spotify, or if I make not mistaken, King. So they have, for example, 1 week of kind of challenge.
Hack week.
Hackathons.
Yeah, exactly.
Hack week.
So it's a good kind of motivating them to go and then search for the state of the art and then implement it, and then say there is a competition, and then that would be a nice way. But I don't know if, for example, other companies, big companies.
I think universities are missing out on this, and if they don't, start doing this, the whole, online movement with, Joe Rogans of the world will take over education in the future.
But we are touching part of my postdoc research, which is part of the answer to become data and AI ready as an organization. The organizational aspects is actually to create a learning organization and learning culture by design.
That's it.
Right. So how do you design learning, right? How do you design harvest from what has been done in one use case in a company somewhere else? How do you design this? Because in the matter of fact, in the company, if it's not measured, if it's not invested, if it's not prioritized next to all the other competing priorities that you need to live with, it won't happen.
No.
So you need to design learning. And it can be done, but you need investment in it. You need like Ericsson had their Ericsson University, always fantastic. The big Scania has a fantastic university internally around lean. One of the best lean courses and black belts you can take in the world. Yeah. So you need to take that concept into data science ultimately, if you're serious.
So we just have 15 minutes left now. So let's
so
try
time flies.
Let's try to keep. We'll take a number of topics, but do it really quickly and try not to go too deep into them. Sure. I'd like to start by the Jeremy Howard quote. And Jeremy Howard is this person. He started Kaggle, the big platform for doing competitions with different data science data sets and problems. And then today he's the president of Fast AI and founder. And he said a quote that is, most research in deep learning is a complete waste of time. Mm-hmm. And if I were to try to interpret what he means with that, is that we see so much research in deep learning, especially saying, who can beat the leaderboard for some specific data set and problem with 0.001% accuracy? When in reality, if some company want to really make use of some deep learning technique, there are so many other challenges that are so more important than having this, 0.1 or 0.01 additional point of accuracy. Mm-hmm. For one, would you agree with this, that the research is a bit wrongly prioritized today in deep learning?
Yeah, I can say I agree with him. So again, I can repeat what that quote about the big data that I mentioned, the relation between big data and teenager and sex. So I think many people or many research groups are working on deep learning without actually doing real research on it, and even without knowing why they need to apply those techniques.
Theoretically on deep learning concepts rather than what's the applied problem we are solving.
Exactly. The first question is that, do you really need deep learning for that problem? For example, you assume you have a fraud detection problem. And you are working in a bank and say, okay, your boss said, okay, now go and use deep learning. But is it the right approach? Maybe other techniques, for example, using the graph algorithm give you better results. So that would be one possibility. Another possibility is, of course, the lack of resources. So if you want to train a model and then improve the accuracy, so you need to have some resources. Actually, I listened to the kind of videos that he described that code, and then I agree with him. He proposed two kind of approaches that many companies that take advantage of those to be able to use deep learning and have it improve it. So one is to use transfer learning, definitely. So if you can, for example, it doesn't make sense to train the bird from the scratch. So borrow a bird, fine-tune it, and use it. Or active learning. So you have huge amount of time, huge amount of the data, and you cannot use all the data, and you don't have enough resources. So use a smart way to extract part of the data and then train the model. So I agree. So without using the resources, the data, the models in a smart way, the energy that you put on the using and training the models would be a waste of time, because you may not get in back fairly according to the time that you put on them.
Yeah, so I think, for one, people, when they hear that quote, for one, think that research is bad. And I think that's a wrong conclusions to make. Right?
Research is bad.
Yeah, that research, is a waste of time. And that's the wrong conclusions to make, right? So research is really needed. And,
of course.
And it's, the pursuit of knowledge, which we of course need to do. It's just that we need to focus on the right questions, right?
Exactly.
Yes.
Exactly. Use the right tool for the right problem. Yes. Otherwise, it's a waste of time. Yeah. But without research, we cannot.
And I like what you said before, that you really try to find, the real motivation for why are we doing this. And if you don't have that holistic understanding of it, you could potentially go in, completely wrong direction and waste your time.
Yeah, and maybe that's the point then, that it's a little bit like a lot of concepts. The concept itself, it becomes more important than what it's used for. I take the analogy, we need to become agile. So banks go and say, as long as we become agile, it will save the world. Hold on, what's your business going to do, and how are you going to solve it for your customers? Then agile can be an enabler on the way, but don't let agile or deep learning be the game in itself. Yeah. And maybe that's back to research, that you get too deep into your topic that this is the holy grail in itself, when it's actually deep learning in relation to what. And if you always explore it like that, then you will find very interesting research areas about active learning, transfer learning in relation to solving this problem with deep learning.
Exactly.
This becomes even more important. Yeah. I think that's the big bottom line.
Yeah.
Cool. And should we take another topic we'll see if we can finish this in time. But okay, so one topic we have spoken a lot about is a singularity. And let's try to find a different kind of angle on this now.
Yes.
And then if we take the two topics of AGI, having an artificial general intelligence versus singularity, some can say that, AGI is the time when we have super intelligence and we have a type of AI system that can be more general than the human brain can be. Mm-hmm. And singularity, I would argue potentially, and please comment me on this, but singularity is a bit different, and that can happen much sooner, I would argue, is when we lose control of systems. So at some point it can be that we lose control of how an AI system is take over the market, the stock market, for example. Or it can be that singularity happens when, drones go rogue and are killing people that may not they're not supposed to, or it basically means the loss of control in some way. Have you thought anything about these terms? What does singularity versus AGI mean, and what's your thinking about this more philosophical terms?
I've never thought about the difference, but I think human always is smarter than the machine, so I'm not sure if
always, always, or just right now.
So far,
yes.
And I think that difference. Actually, I cannot say for sure, but I think with a high probability we keep that distance for future. But anyway, so
if you were to guess a date on AGI, a point where single AI system, I'm not saying a single AI model, but a single AI system can basically beat a human for most tasks. What can you just estimate a date for that? Are we speaking 10 years, 50 years, 100 years?
1,000 years.
Maybe if we have quantum computing.
Don't go there.
No, yes. Yeah, so then we may actually achieve it.
But it's always so difficult with this question, because what is human intelligence, right? Because we, in some ways, machine intelligence can be better than humans on narrow tasks already. We know this. So what is it that makes up human-like intelligence?
Yeah, and general intelligence, humans are far from general.
Yeah, this is the point, right? Human intelligence is not really superior. It's not really superior at all. It's
superior, but it's not general.
Maybe they beat human for many tasks, but some tasks, I don't think so. For example, these are relevant to emotions or to the kindness.
Can you give an example?
Yeah.
Happy, sad, love.
Happy, sad, love. Exactly.
I haven't tried to define it a bit more clearly. What do you mean happy?
Yeah. No, for example, how can
I can build a rule-based system with 2 lines. If 0, sad. If 1, happy. Now I have a system that can be happy and sad.
But happiness doesn't have a fixed definition.
No, not for humans either, right?
Yeah, so that's what I mean. So, for example, for 2 people, so you as a human may realize that how to behave with a kid to, calm him or her or happy them and so on. But maybe this simple. It would be simple for the machine, but something more emotional. I don't think.
But something that has human-like intelligence, AGI. Does it have a soul?
I think human level intelligence is different from AGI though. But let's call it Jan LeCun, the pioneer in deep learning and director of AI in Facebook. He's really being clear that we shouldn't use the term AGI for human level intelligence, because it's 2 different things. And human level intelligence is very narrow and has a very specific, like computer vision or human vision kind of narrow intelligence. But AGI is actually much more general than human level intelligence. But in any case, our AI is far from human level, and it's super far from AGI as well.
Yeah. No, but right. I haven't really thought about it before. But if we talk about intelligence in a robot on this level, does it still mean that the robot does it need to have a soul, feelings? Does it have feelings or not? Is human level intelligence meaning that the machine has feelings? Because it can reason with me, it can be smart, it can be intelligent, but EQ wise, emotionally, I mean, like, okay, you can even sense my emotions, so it can respond to it. So in some ways, it needs to be able to be empathic. The machine needs to be empathic to my emotions. Does it have still emotions? Probably not.
And what do we do with the belief? So, for example, the reasoning behind person with some, which is
values and beliefs,
who doesn't believe in God, and someone who believes in God. So maybe the reasoning behind them are totally different.
Yeah, the values are
different, and then so the meanings are different for them. And then when we talk about the super machine,
so it's to be a human level intelligence. Does it has value? Does it have its own ethics? Does it have all this?
Yeah.
Because that's part of moral. Does it have moral?
Yeah, that's the point. Yeah.
I'm super eager to say what I
So
think.
what do you think? What do you think yourself when?
Let's take it easier. If you have a car, and it's a cold winter night and it doesn't start, would you call and say that this car right now is sad and tired and doesn't want to start?
It's sick. It's sick.
It's sick.
It's sick. Yeah.
I mean, this is the type of anthropomorphizing, using human terms to describe a complex system.
Yes.
I would argue that humans don't have like an inherent thing called an emotion or feeling. It's a way of using our language to describe a very, very complicated system that humans has. Mm-hmm. And it's very useful because it understands, if you are especially angry one day, it's very useful to me to use the term angry, just as well as it's useful for me to use that term about a car that is, doesn't want to start a morning. And I say, the car is actually very tired or sad today. It's useful way to describe a very, very complicated system. It doesn't really describe the reason for it.
No.
It's just like a very abstract description of a very complicated system.
But because that's the complexity with the human, right? I mean, like from what I'm angry, I'm annoyed with you because my brain neurons has done something. Yeah. My face got red, my fist got punched, But in the end, the physicalities and my emotions, if you think about your emotions, there are neurons going on in here.
Yeah. Exactly.
So, yes. So when we say human-like intelligence, you probably can have all the things like this, but be completely cold on the inside, or can you? So it's very, very, philosophical, but it's fun. It's fun
with philosophy sometimes.
Yeah, or something such as for some actions, such as crying. How you interpret it. So it could be based on the happiness or sadness.
Yeah. But in one way, why it's quite interesting to philosophize like this and have fun with it is because it sort of demystifies and makes a joke out of some of these propaganda type arguments, or machines will be like humans. No, it will never be the same. So it's a little bit like, let's focus on, what singularity, the definition I think that you highlighted, when do we lose control, is more scary than, the more philosophical idea of what is human-like intelligence, because we can lose control much earlier. So, but I think just by having a discussion like this, it also highlights, well, it is a machine, right? So does it really matter?
And just to end, on a more positive note as well, because we often end of these kind of negative dystopian kind of discussions.
I mean, you just killed emotion, so good luck with that.
But thinking about, we have a pandemic right now, and we have, we don't want this to happen again, and we know that a data-driven approach using machine learning and deep learning can help with things like, drug discovery and alleviate a lot of the overload that we have in the health sector today and whatnot. Mm-hmm. And we have a big, economic impact that will happen now in coming years. Some people say, and it would be fun to hear what you think, Amir, what is the best way to find the positive use of AI for the society? And I would argue, and this is that, humans are today certainly much better than AI in some ways. And AI is better than humans in some other ways, especially when it comes to going through a large amount of data, which humans can't really do in a good way. But AI is very superficial, and humans are much more in-depth and have a broad generic knowledge and reasoning capability that AI have not. So if we combine the two, we can find the best of both worlds. Would you agree that this would be a...
Yeah, of course, both AI and human can support each other. But one possibility that we can use is to predict. One of the main capability of the AI is to predict the future.
Yeah.
And then from that perspective, it can help human to prevent such catastrophic to happen again.
Sounds great. Cool. Amir, what's next in your life, either professionally or personally? What's
looking
happening?
forward to become a docent, of course.
Yeah, so
Yes.
that's the first thing. But yeah, so professionally, as I mentioned, so I'm really interested to enable non-AI or non-expert people to be able to use machine learning and deep learning and try to make it possible for more people to take advantage of the technology. That's my plan.
Sounds great. Amir, is there anyone that you would recommend to come on this podcast? Someone that you perhaps would love to listen to yourself?
Oh. So that's a good question. So many of my colleagues are actually, I like to listen to them. And also I like to listen to Jim Darling,
Jim Darling.
From Logical Clocks.
That's a good idea, actually. Yeah. He's working on some cool stuff.
Yeah.
And
how long has he been working on that?
Actually, we can get him, I guess.
Yeah, of course.
Yeah. But how long has he been working on this the project, or when did he start up the company? I'm just curious.
2015, 16.
Yeah. Okay.
If I'm not mistaken.
Anyone else that you can think of?
Thanks again for inviting me. And actually, I can say that I'm interested in AI, I'm interested in technology, but I think life is not only AI and technology.
What do you say? Are you cursing now on the AI podcast?
There are other dimensions in life that we need to...
That's very true. Very true.
Good time.
Yeah. So, but actually, that means you need to come back, because this is an AI after work. So we talk with AI people about every topic the person wants to talk about. So if you want to talk about fishing, let's talk about fishing.
AI and fishing.
Oh, without AI. Non-AI fishing, perhaps. I don't know. Awesome, Amir. It's been a true pleasure, as usual, to speak with you. And I hope that we can have another episode at some point in the future.
Thanks again for inviting me.
Thank you
so much to come.
Thank you. Cheers. Thank you.